Welcome back. So this week we're doing assessing acceptability. So we're starting in on the whole half of the course where we're evaluating whether arguments are any good rather than just diagramming them and try to understand their structure. Now we're trying to decide whether they're good or bad arguments. And that gets us into increasingly informal considerations where you're having to bring your background knowledge and your common sense, your compassion and your insight to bear in order to make serious judgments about these things. And as I've been suggesting all semester, this is not something that I'm imposing on you as a weird condition of this class. This is actually the condition that you experience every day in your everyday life all the time. And hopefully this class is giving you some tools for dealing with that problem in more rigorous ways. So we're doing, this week we're doing, today we're doing assessing acceptability, and that's one of the steps in your textbook. They break your steps for assessing an argument down into 7 steps. The following are these 7 steps. So identify the conclusion, identify the premises, and identify the structure. That's making a diagram. So that's the whole first half of the semester. We're doing the first 3 steps of assessing an argument. Now we're going to move into checking the premises for acceptability, checking them for relevance, checking them for adequacy, and I don't know if we're going to focus specifically on considering counterarguments, but that's the kind of final step in the process. So once you've done that, you'll know whether you think the argument is good in the sense of being both valid and or sound, right? Because today we're going to talk about checking premises for acceptability, which is more or less checking them for whether you think they're true or not. So of course, a true argument not a true argument. Arguments are valid or invalid. A valid argument with all true premises is of course sound, and you should always believe the conclusions of sound arguments. So this is the step that turns a valid argument into a merely valid argument into a sound argument. And then of course, relevance and adequacy we'll do next week, Wednesday and next week, right? So the number of concepts to go over today, including the idea of empirical claims, some of the ways that we show empirical claims are true, such as inductive generalizations and statistical syllogisms, and induction by confirmation. And then we'll contrast empirical claims with a couple of other types of claims, normative claims and foundational claims. And then we'll go through some fallacies of acceptability. So there are basically 3 different ways that something could be true. A premise could be acceptable. It could be an acceptable empirical claim, or it could be an acceptable normative or foundational claim. And I believe on Wednesday we're talking specifically about normative claims, because there's a whole bunch of complexities and wrinkles in going from a state of the world, so a descriptively true statement, to a statement about what should be the case or what we ought to do. And I would take it most of the arguments you're actually going to encounter in your life have some normative dimension. There's an argument about what we should do, which actions we should take, rather than a straightforward argument about just what is the case in the world. It's much more complex to argue that something should be the case or something that we should do something than just to argue about the brute facts of the thing. So that's what we'll do Wednesday, I believe. And then on the 7th, it's a civic holiday, so there's no class 1 week from today, right? You have the 7th off. And then on the Wednesday, we'll move on to the other steps. There's 2 other steps, checking for relevance and checking for adequacy. Okay? There's a quiz technically due this Friday. I think I'm going to extend that deadline till Sunday because I have not yet written the quiz. So you get more time. I think it's going to be a short one. I think it won't be 30 questions. It'll be 10 multiple choice or something like that. So that won't be a big deal. It's just to have one more piece of the story about how you're keeping up with this class. You're seeing these kind of questions across different contexts. So I think it's actually cognitively helpful to answer the question from your house as well as from your seat in this classroom, so you don't get kind of locked into this context. So, right. I will keep you up to date as soon as I post that quiz, and I believe I'm going to extend the deadline, so you'll have at least several days, not just 24 hours or something to answer it. Okay? Okay. So, empirical claims. These are one of the 3 kinds of claims that we're going to be looking at today, and they are true based on some facts of the matter. So to be empirical is to be based on or related to observations or evidence. That's what the word empirical means in this context. You've probably also heard it as the same thing as scientific. So you say it's an empirical fact. What they mean is that it's a product of a scientific research project. But that's not what we're going to mean in this class. So in this class, when you say something is empirical, what we mean is it describes a state of the world. So the cat is on the mat. You can barely see the cat here, but is a statement about the arrangement of objects in the world. And it's the kind of statement that cannot be determined to be true or false based on just the words, right? You need to actually look. Is the cat on the mat? So in the language we were using before, it's a synthetic claim. And all empirical claims are synthetic claims. Right. So here are some claims, and try to decide whether these are empirical or not. So this shape has 3 sides. Empirical or no? Yeah, because I'm just pointing at it and saying this shape, how many sides has it got? Look, it's got 3 sides. And you figure that out by counting the sides, obviously. Now, if I say triangles are 3-sided figures, that's an analytic statement, right? You can tell that that's true just based on knowing the meaning of the words in that sentence and how they're arranged. Similarly, this triangle has internal angles that add up to 180 degrees. So the point of these is to get you to separate what could be measured from what must be measured. So when I said something is empirical, if it's related to observations or evidence, you could perfectly well take this triangle and measure the angles and add up your measurements and see whether they add up to 180 degrees. You totally could do that. Just like you totally can check whether having 2 apples and having 5 apples mean you have 7 apples. Right? You can check those things. But you don't have to check those because this triangle has internal angles that add up to 180 degrees. Anytime you're on a 2D plane, that is automatically true, right? You do not have to measure, you just know. By knowing the properties of triangles, you know that all triangles have internal angles that add up to 180 degrees. You can prove this using Euclid's axioms. So to say something is empirical does not mean to say that it has to be checked. To say something is analytic, it could be checked. It doesn't mean that it has to be checked. Yeah?
So when you say this shape has 3 sides, you're including the picture of part of the argument, right? Or the statement, right?
Yeah. Yeah. I guess so. So you definitely need to know the reference of this. But I guess so what we're asking is, given that this has the reference of that, does this statement empirical or not? Yeah.
So the way the sentence is structured does not affect if it's an analytic or synthetic claim. Because for instance, if I say this triangle, I'm pointing to a particular object. But then you said that triangles will always have, which is right, have internal angles that always have 180 degrees.
Right. Right. So the difference there is whether you've included that this object is a triangle. So there's nothing in the word this. It's the context that sets the reference of this. So this doesn't always have 3 sides, but given that you can make an observation of this, now you know that it has 3 sides. So it's the identity of the reference of this in that sentence, which is contingent. Okay. All right. So another way of teasing apart, so again, it's observation. So an empirical fact is a fact that must be checked by observation. But that doesn't mean that you can always check by observation. That it doesn't mean, don't confuse that with a claim that an empirical fact is always checkable by some practically, like some observation that we could actually make. So here's an empirical claim. There exist galaxies outside of the visible universe. This is supposed to be like you can't see it, but it's one of those maps of the simulation of the large structure of the universe. So the visible universe is the universe that is close enough for light to have reached us since the Big Bang. So like a very large volume of the universe, but as far as astronomers can tell, it's not the whole universe. So there's areas outside the visible universe that we cannot see in principle, right? Just according to physics. And yet, so there is no observation that you could make. If general relativity is correct, there is no observation, even in principle, that we could make that would check whether there are galaxies outside of our visible universe. So there's just no method that you could perform that observation using. However, it remains an empirical claim because there's a fact of the matter, right? You know what observation would be relevant to checking it. Like if you were 100 billion light years over to the left, then you could check whether there are some galaxies outside of our visible universe, right? So it's about whether there is an observation which would confirm or disconfirm, and whether you need to make that observation to confirm or disconfirm. In our case, we assume that there are galaxies outside of our visible universe because there's nothing particularly special about where Earth is. Do you want to know a sad fact, a sad astronomical fact? There are galaxies outside the future visibility limit. So the visible universe expands as time goes on because it's how far away it is from us according to the speed of light, or like how you can only see things that are within the past light cone of Earth. And astronomers think that even beyond, so there's a limit for where that future cone is gonna be, or the sphere of a visible universe is gonna end up. And astronomers believe that the universe is expanding faster than that is expanding, right? So the universe is getting bigger at a rate faster than our visible universe is getting bigger, which means that no matter how long time goes on, there are parts of this universe that we can never, in principle, visit, ever. Cannot even not visit them. You can't even see them. So we're all drifting apart in this cosmic way. I find that kind of sad, a little bit. Even more, this is less important. So I want to say, just for the purposes of talking about what's empirical, stuff outside the future visibility limit is really, really kind of, according to the laws of physics, outside of the range of things that we could possibly observe. But that doesn't mean that it's a contradiction to say that there are objects outside the future visibility limit, right? There probably are. Assuming that Earth is not any special weird place in the universe, there are. So it's an empirical claim, but it's not one that we can actually check. What makes it an empirical claim is that there are some observations that would confirm or disconfirm it if we could make them. And furthermore, it's not true in principle, and it's not a contradiction. Right? So that's how you sort of limb the limits of what's an empirical claim and what's not. If it's a fact of matter, fact about the world, and you know what observations would confirm or disconfirm it, and it's not an analytic truth, and it's not a contradiction. Okay? Yeah?
Would all dogs go to heaven be empirical?
Yeah, I think that's an empirical claim. All dogs go to heaven is an empirical claim. And as we discussed last time, we know what observations would confirm it. Die and go to heaven and find your dog there. Even if you can't, in practice, do that. Yeah. Okay? Okay. So an empirical claim is the sort of claim that has to be checked in order to be believed, or we have to know what kind of observation would be able to check it. So that excludes facts that can be checked by other means, for example, knowing things that are true by definition. So if it's true by definition, then it's not an empirical claim. So triangles have internal angles that add up to 180 degrees is not an empirical claim, even though you can check it by adding up you can measure it and add them up. You'll get like 179.5 or something. But you can do it. And furthermore, it does not mean that we can check it. So that was the point of the last couple of slides. So empirical claims are the kind of things that have to be checked in order to be believed, and we should keep out of the class of empirical things that can be checked by other means, and we should not think that the class of empirical things are things that we can, in practice, check. That felt convoluted coming out of my mouth. Was that fairly clear? Yeah?
So when you say check, what exactly do you mean by check? Like something you can actually observe?
Yeah, should be something observable.
Because you can like intellectually observe something, like not visibly seen.
So through your perception, yeah.
Oh, okay. So that includes also like cognitive.
That's tricky because I don't want to say just rational reflection is a method of empirical investigation.
Well, like let's say you have like a math theorem or something, and you just state the theorem, and you can
Yeah,
check
that's
that
what we
out.
want to. That's exactly what we want to exclude. Is like doing a derivation in math is exactly the kind of a prototypical analytic proof of something.
I see.
So that's when you know it's true by, given the axioms of this deductive system, we can prove this theorem. That's something that you don't have to go into the world to check.
I see.
It's just a rational consequence of something that you've presupposed. Yeah?
I see.
Yeah. I saw a hand. Did I see a hand up here? Okay, yeah.
So what's the difference between analytic and empirical then?
So it's all synthetic statements. No, let's say. So mostly it's the synthetic are empirical, analytic are non-empirical. But there are a couple of other classes of non-empirical ones that I want to talk about. So there's things that are true by definition, but there's also normative claims and foundational claims. Right. Okay. Yeah.
So what if I say I toss a coin and it'll land heads or tails, right? Heads or tails. So is that empirical?
Yeah, because you know by definition, like a coin has either heads or tails.
Right. So
Or actually, you would add to that, say heads
on
or
the
tails or
side.
on the side.
Yeah.
If by definition it's true, right? Does it count?
Yeah, 'cause you.
So yeah. So if you say I flip a coin, it's either got to land heads, tails, or on its side. Yeah, that gets into by definition. It's not completely clear to me. Yeah, it depends on what possibilities we allow.
Perfect system. I mean in a perfect system.
Okay. So this is relevant. So you add in, so you can make it either empirical or analytic by adding or taking away the things that you presuppose. So in a perfect system where a coin must land on its head, on its face, on its tails, or on its side, then it must land on its face, on its tails, on its side. That's an analytic truth. Whereas if if you flip a coin out of your spaceship and it falls into the sun, it's not going to land on any side. It's going to vaporize and not land on anything. So there are conditions under which a flipped coin doesn't land on any side, so none of those possibilities actually occur. So it depends how much you build into your presuppositions, and that's a really important point, actually. Yeah. Yeah.
Does it mean that the empirical claim that must be checked comes before the claim or after the claim? Like to claim that one fact is an empirical claim.
Sorry, I can't quite
So
hear.
like to check to know if one fact is empirical claim,
Yeah.
does the must be checked comes before or after?
So the must be checked is the condition on whether something is an empirical claim or not. Does that answer your question?
So
Okay.
it should be checked to claim one fact is an empirical claim, right?
It's not that it should be checked, it's that it's checkable. That it's possible to check, and you know what would be the kind of thing to check. Yeah? Okay, yeah.
So just to like summarize for just me, but like when you say something's empirical, does that mean like you don't absolutely 100% know what the truth is, and you have to check it in order to get either the truth or get close to it? Because like that thing that we just talked about, like or it can also be expanded to like math proofs. Like if you have like a theorem, presumably assuming that the person says it is actually a true theorem, like that's a necessary truth.
Right.
Hence it being a theorem.
Right.
So you don't actually have to like check something because it's a necessary truth. But like something like flipping a coin, it might end up in the sun or something like that. Example like that. You don't know that for a fact, but you have to
Yeah.
observe it
Yeah, I
to
mean,
sign a truth statement.
yeah, usually we say that you should have less than perfect certainty. About any empirical claim, you should have less than perfect certainty about that claim. But that's true even after you've checked it. Like, because observation is fallible, because you can always be tricked or be mistaken, that kind of stuff. So yeah, empirical claims are kind of, because of the way we've defined them, they're kind of unreliable by nature, right? So it's not true by definition, so you don't have that kind of certainty. It's got to be checked by observation, and observation is a kind of messy whole thing. So yeah, you kind of get a little like, you get a fraction of skepticism built right in. Yeah. Okay, good. So I want to make a distinction between two types of general empirical claims. So you can have a very specific empirical claim, like the cat is on the mat. That's a claim about exactly one scenario, like a cat and a mat and on. But we can also make general empirical claims, and these are trickier to establish. So we can distinguish statistical claims from universal claims. So the statistical claim would be something like most swans are white, or 95% of swans are white. The universal claim would be all swans are white. And this should remind you of the generic universal stuff. So this is a universal statement, and these are sort of weaker statistical claims. And of course, the kind of evidence you need to bring to bear to prove either one of these is different, right? So proving all swans are white is kind of like this is just like we were just saying, it's kind of never completed, because you can observe as many swans as you want. Unless you've defined swans as white birds, no matter how many white swans you observe, it never rules out the possibility of a black swan turning up, like this one. You can get much closer to prove, so most swans are white, if you believe that swans are defined in terms of being a species on Earth. So now we have a pretty good shot at getting a representative sample of the population of swans. Proving 95% of swans are white is much easier than proving all swans are white. So it's a weaker claim. And most swans are white is a weaker claim still. So you just have to get a majority or something like that. Okay? So the conditions under which we believe general empirical claims. All right. If that's fairly clear, I mean, you guys have been, none of you would have gotten this far in your life if you weren't like pretty good at checking whether things are true. So we're kind of just like getting some names on various parts of this process. Yeah?
So at what point can you like start saying all dogs have 4 legs? You obviously can't say there's no such thing as a dog with 5 legs.
But there are in fact dogs with 5 legs. Yeah.
At that point, when can you
Yeah.
start saying like all swans are white?
Well, depends on whether you care to have absolute certainty or not. If you care a lot about being completely certain of everything, then you should always like dial your claims back. You should never make these extremely general claims. And this is sort of built into the way scientists talk, right? So scientists always talk about their theories. They talk about the theory of relativity. They don't talk about the I'm absolutely certain about this of relativity or something like that. It was a very unlovely phrase, but yeah, so if you want to make these universal claims, you kind of have to accept, if you want to make universal empirical claims, you kind of have to accept that you can always be wrong, because you never have the complete set of experiences, and experience is what's going to prove you right or wrong. Yeah?
That's like the same logic for like Windex when it says like kills 99.9% of the
Right.
Like, who knows?
Right. I think that, yeah, it's very likely that there are some leftovers. Anyway, okay. So we're going to talk a little bit about the structure of inductive generalization and inductive syllogisms. So these are two ways that you can go from a set of observations to either to or from a generalization. So inductive generalization is when you do this, when you say some percent of observed Fs are G, so 95% of swans are white. It is probable, therefore, that X percent of all Fs are Gs. So we're going from a statement about observations to a statement about a population. So suppose this green circle is the whole space of swans that we've observed. So you're a biologist, you've gone into the field, and you've observed a whole bunch of swans. And this is all of them, and you said, 99.9% of these are white swans. And an inductive generalization is when you go from observed facts about a subpopulation or a sample to a larger population. Should be fairly straightforward. This is like half of science, and I'm about to show you the other half in a minute. So a couple of problems that you could have in an inductive generalization. One is this sample large enough? So if you say, I asked 3 random people outside my house what they thought of the Prime Minister, and they all said he was great, therefore all of Canada thinks the Prime Minister is great, that wasn't a very good inductive generalization, right? Because your sample was 3 people and you're trying to make an inference about 40 million people. Now, a poll surveyed 1,000 people to understand Canadian opinions. That's more like it, right? Right? So 1,000 people is considered a reasonable sample to make an inference about a population of 40 million or so under some specific conditions. Yeah?
But even science itself isn't sufficient situation to make your argument strong. You have to think of, were they randomly selected? What were their socioeconomic factors, etc.
So you might say that you have to ask if the sample is representative. So another issue is whether your sample is properly representative of the whole. So for example, psychology has had a problem with generalizing studies from what's called weird, Western educated, industrialized, rich, democratic countries. So practically all of the psych research in the literature is based on, here's the method for getting subjects. The professor is teaching Psych 100, and he says, you get 2% on your final mark for coming to my lab and doing one of my experiments. So that means that almost all of the research subjects for psychology experiments have been first or second year undergraduates at Western universities. And then they take those results and say, this is the fundamental nature of human beings. We've discovered it by looking at this incredibly tiny and weird slice of humanity in this very specific socioeconomic context, very specific life experiences, very specific background. They're all psych students. So psychology's been, to their credit, psychology's been kind of trying to face up to this problem and say, okay, which of our studies are actually affected by, not everything varies from person to person across the world. We share 99% of our DNA with literally every living human, so it's not like there's nothing in common amongst humans. But if you're doing a psychology study about altruism or how people cooperate or any of those really complex human behaviors, and all of your people are from this very narrow slice of the population, you might worry about whether this sample, doesn't matter how big that is. You could have 10,000 people in that study. It's still not going to be representative necessarily of the larger population. A similar, kind of simpler one, it used to be the case that when they did political polls, they would only call landlines. Many of you too young to remember, the phone used to be attached to the wall, and you couldn't walk very far away from it because it was literally attached. So old people had these things at a time when young people had cell phones and old people had landlines, and they would only call landlines. So they would get mostly old people on their political polls, and old people in general have different political opinions, at least on average, than young people. So political polls would skew conservative because they were calling people on landlines rather than cell phones. This is a problem that they've mostly solved. I believe that they've mostly solved this problem by calling people on cell phones and building into their models so what you can do is, if you know that your sample is unrepresentative, but you know how it's unrepresentative, you can build that into your model of how this sample should be treated as a representative of the whole. So if you're well, I got 50% landlines and 50% cell phones, and I know the landlines are 90% old people and the cell phones are 50-50, you can build that into your modeling of the larger population. If you'd like to know more, study science. They're all about this stuff. All right. So going in the opposite direction, look at the direction of the arrows here. So inductive generalization goes from a sample to a general population. Inductive syllogism does the opposite. It goes from facts that you know about the population and infers things about a smaller sample or even just one member of the population. So Z% of all Fs are Gs, so 95% of all swans are white. X is an F. Jerome is a swan. Therefore, there's a 95% probability that Jerome is white. So it makes an inference from a population. You have a population level fact, or you think you do, and then you infer something about the individual. Right? It's the opposite direction of the inductive generalization. This is an inductive syllogism. Okay? So here's what can go wrong with that. Here's an inductive syllogism. 53% of Canadians have some post-secondary education. Some of you are Canadians. Therefore, there's a 53% chance that the Canadians in this tutorial have some post-secondary education. Now, what's the problem with that? Yeah.
Your sample is not selected randomly.
Right. It is certainly not selected randomly. If you're in this room, I just watched you get some post-secondary education. I did it myself to you. So I'm completely certain that everybody in this room, at least, has had some post-secondary education. Maybe not completely certain. I'm 99.9% certain. Unless we're in the matrix, that's what's happening. So you cannot always, by any means, take a population level fact and make an inference that it's going to be the same statistics in your smaller sample. If there's any mitigating factors, if there's any factors that complexify the sort of situation, right, these are ways in which the sample, again, can be unrepresentative of the population as a whole. Yeah?
So it seems like acceptability, and this is at odds here with validity. A lot of these, are we going to be learning, I guess, how to manage these, especially going forward with the paper? Like, how do we balance it? Like, stronger argument?
I think this is pretty much all I'm going to say about this. To be honest, to be very serious, these are the questions that make science hard. And I'm being a bit flippant when I'm say go study science, but that really is the serious answer to understanding how inductive generalizations and inductive syllogisms can be made stronger or weaker. There's a million different factors that go into that, and it's a massively complicated process. So you really do have to, to get beyond this really rough treatment, you kind of have to go take stats, and they'll tell you how to think about this in a much more rigorous way than I can. Yeah.
So are we paying attention to these elements, specifically the induction part, when we're analyzing our texts?
Should be.
So, but how do we state what they meant to say? Do we turn it into just deductive style logic, or we just keep the, when they say most people agree that yada yada yada?
Basically, from here on in, we're not going to be turning things into deductive style logic.
Okay, so just as they're saying it, and if anything that we think is reasonable to add to it.
Essentially, yeah. The arguments from now on, the arguments we're going to be dealing with are kind of real world, in the wild arguments. I'm not going to give you toy arguments anymore. I'm going to start giving you arguments that people actually make, like in newspapers and online. And you'll find that, doing this through examples is the only way I know how to do that. And please keep these in mind. So if somebody makes an inductive generalization, or they do an inductive syllogism, what I want for you to be able to do is spot that and ask yourself, okay, does that sound reasonable to me? And the limit of being able to do that is having a full background in statistics and scientific method. Obviously, I'm not going to do that in the next 2 weeks, give you the full background in statistics and scientific method. So I think that taking it to a more formal place wouldn't be productive for our purposes. Basically, what I want you to know is just be able to spot these moves in an argument and be able to recognize the major ways, the most common ways in which they can go wrong, pardon me. So the most common ways are, of course, that the sample doesn't represent the population, or the population doesn't represent the sample, or your sample's too small. Those are the kind of standard ways in which these inductive generalizations go wrong. Yeah. Yeah.
Oh, sorry, but what if in the argument they didn't say they didn't give you any information as to that, no sources, no nothing. You're just a claim that most criminals should be executed.
Yeah,
Okay. And then Bob's a criminal, therefore he should be executed. How do you analyze that? Do you just say how reasonable is that, or?
You're going to have to use your judgment.
Okay.
You're going to have to look at the context, and you're going to have to look at the stakes of the.
Okay.
So if I was Bob, I would think that the stakes are extremely high in your example of,
Right.
oh well, most people deserve to be executed, so go ahead and execute Bob. I would find that to be quite unacceptable as an inference and demand far more specific reasoning for that case. So partly depends on the stakes of what's involved. It depends on the level of controversy for the claim to be established. So if I say,
Or even if there is controversy.
yeah, exactly. So if it's something that's heavily debated, and then the steps you need to take in order to check whether it's acceptable enough are different than if it's something that's not disputed. If I say, last Wednesday it was kind of hot outside, you don't need a big study to prove that to you, especially if it's not a big part of the argument or something like that.
Right.
Okay. Yeah. Good. So here's another inductive syllogism that kind of goes wrong. Well, it's a better one. It's a better one. Anyway, so almost every human has caught a cold at some point in their lives. You are all humans. Therefore, it's very likely that you've caught a cold at least sometime in your life. I would be surprised if any of you, I would put your hand, if you've never caught a cold in your entire life, put up your hand. Never, no, stop. Right, okay, so in this case, it was a successful inductive syllogism, right? We successfully went from a population level fact to a sample level fact. Right? You are a sample of humanity. We made a nice inference about what's true for practically everybody to what's true for us. Yeah.
Okay, if you change the cold to some rare disease, asking this population would be pretty unfair, right?
Well, it would make the first premise so.
Instead of cold, you ask some kind of a question about a disease that's general located, right? Like something that's only below the equator or something, like diseases that are found below the equator, and you ask us.
Right. Right. Well, that would negate the almost every human. So if it's almost every human who lives below the equator has caught this, then it wouldn't apply to you. And if it's something that doesn't follow the almost every, then it doesn't apply. Here's another way in which it doesn't apply. Take a newborn baby. Newborn baby is a human. Newborn baby is pretty unlikely actually to have caught a cold. They just haven't had time yet, right? So if you go, almost every human has caught a cold at some point in their lives, you, newborn baby, are a human. Therefore, it's very likely that you've caught a cold sometime in your life. Doesn't work, right? So it's not the case that this kind of inductive syllogism always works, and it's a question of how representative the sample is of the population. Same thing with inductive generalization. Is the sample representative of the population? Yeah?
Is there kind of like an implicit sort of thought that that first statement excludes newborn babies or very young humans?
Well, as it is, it doesn't have to, right? Because you can still say almost every human, even including newborn babies, you still have like 95% of the population has caught a cold at some point in their life. So that's, for me, that counts as almost every. So it's still true, right? Almost every human has caught a cold at some point in their lives is true, even if you include the newborn babies and people who live in sealed bubbles and whatever, like, because they're such a small part of the population. But if that's exactly the part of the population you happen to be dealing with, then your inductive syllogism doesn't work, or it's not going to give you the right answer. Yeah?
Or let's say the text said by human we mean mature.
Sure. That would fix it up. Yeah.
Right.
Yeah. Yeah.
Or if you put it in the future tense, then babies will be included.
That's right. Yeah. So therefore, it is very likely that you will catch a cold at some time in your life. Yeah. It doesn't make it certain, but it does make it very likely. Yeah. Yeah. Good. Okay. So you're all doing this stuff all the time. So I'm not teaching you any like ways of thinking that you're not already employing all the time. I hope what I'm doing is putting a label on it such that when you see it, you can identify it positively. You say, this is what's happening, and then you can ask yourself meaningful questions about it. Like, are we dealing with a representative sample? Is the sample big enough? That kind of thing. Okay. Here's one that I think is really good. I tried to set it up so that it's really good. So 33% of atoms in a sample of pure H2O at neutral pH are oxygen. This is a sample of pure H2O at neutral pH. It's not, but imagine it is. Therefore, 33% of the atoms in the sample are oxygen. I think that's a darn good inductive syllogism. And I think I've set it up to be that way because what do you know about what are the facts about H2O at neutral pH? Well, it's two H's and an O. It's right there in the name. Therefore, if it's a pure sample at neutral pH, that's how many 33% of the atoms are going to be oxygen. So in cases where you have perfect knowledge of the sample or of the population and the sample is perfectly representative, now this is a really good syllogism, right? It's a really reliable one because of the perfect representativeness of the population for the sample. Yeah?
Is that first sentence an analytic one or an empirical?
I think it's analytic. Yeah. Yeah. So this might end up being not an empirical generalization at all, or you're not moving from an empirical generalization to a empirical claim. You're moving from one analytic claim to something that falls out of it. Yeah. Okay. So here's one more way of doing empirical sort of population to sample stuff. It's called induction by confirmation. So if H is a hypothesis, then we should see O, which is an observation. We did see O, the observation. It is probable, therefore, that the hypothesis was true. Okay, so this makes an inference from observations to a hypothesis which is supposed to explain them. It's also called inference to the best explanation. So you see a phenomenon, it's confusing and strange and unexpected. If you have a hypothesis that would explain it, then that strange, unexpected, confusing observation is evidence for the hypothesis being true. Assuming it's the only population that can explain, or the only hypothesis that can explain it. Yeah?
So why probable?
Why what?
So why you say it's probable, why not just say therefore H?
Well, because, so why not just therefore H? Because you might not be certain that H is the only hypothesis that would explain it.
Well, then your statement, if H, then O is wrong, right?
No, no. So if H is true, then O would follow.
Oh,
Right, good, good. Yeah,
So you said, so if H then O, you said O, and therefore it's probable, H is probable
Yeah.
because of that.
yeah.
I see. Okay.
Okay, so let's do an example to get this out of the abstract. Oh, actually, yeah, let's do this example first. Okay, so here's an actual inference to the best explanation from the history of science. If the theory of general relativity is true, then it follows that light rays passing near the sun will be bent. So the sun bends, according to general relativity, the sun bends space-time by its gravitational attraction, or its gravitational attraction just is the bending of space-time, which means that a real star behind the sun, its light will get deflected and arrive at Earth looking like it's coming from somewhere it's not. Yeah? So if you see this weird thing that stars are showing up where they shouldn't show up, then you can explain it using the theory of general relativity. We observed that. Therefore, it's probable the theory of general relativity is true. Okay, so, and this was one of the early confirmations that general relativity was a good theory. They watched just at an eclipse, I believe, so that you could see really close to the sun, and they watched which stars appeared right next to the sun, and they were the wrong stars. If space was just flat, the wrong stars were showing up, but it was exactly what Einstein said would happen because of the bending of space-time. Yeah.
But is that because you're saying like if A then B, you say B then probably A? Is that kind of assumed that you're somewhere you're interpreting that A is being the only sort of
That's right.
reason for that? Because
Well,
otherwise you said it's possible that
okay, so here's a,
kind of like really
let me do another example that is a bad inference of the best explanation. So if someone were secretly stealing my money, I'd end up broke. And I'm broke, therefore probably somebody's secretly stealing my money. Ha-ha. Ha-ha. Okay, but that's not a very good inference, right? Maybe I just didn't make all that much money, or maybe I spent it all. Those are perfectly good hypotheses which would explain my lack of extra money, right? Right. So in this case, I'm advancing a hypothesis to explain an observation, but it's by far not the only hypothesis. And furthermore, it's not even a very plausible hypothesis. Yeah?
this just seems like instead of, like, this would only hold true for, like, not just true bicondition, but, like, general bicondition.
Yeah, so if and only if this hypothesis is true.
Generally,
Yeah, yeah. Notice, so we'll go back to this. So notice the similarity in structure between this and the fallacy of affirming the consequent. So here's a fallacy of affirming the consequent. If x then y, y therefore x. That's a fallacy. That's formally speaking, that's a fallacy. But you can make it not a fallacy by saying if and only if. That's kind of weird, right? That should strike you as weird.
So is induction by confirmation useful if you have any good reason to believe that the antecedent is sort of unique to entailing the consequent?
That's right.
Or
So,
like a very limited amount of things?
that's right. So to go back to the general relativity example,
Yeah, like that's
at the time, Einstein's theory of relativity was the only hypothesis on the books that would predict that the stars would show up in the wrong place near an eclipse. That was the only theory that anybody had thought of. That's not to say it is the only possible theory, of course, right? So it's not that we can rule out all other hypotheses just completely, but at the time, there were various physical theories that were being debated, and of them all, Einstein's was the only one that predicted that light rays should bend in a gravitational field. They observed light rays bending in a gravitational field, And that leads, so I want to emphasize that that makes it probable that Einstein's theory was right. So it's inference to the best explanation. We got this really weird thing. Light seems to be bending. I've got a theory that would predict light would bend. That makes the theory more probable. Right? It's the best explanation available, and therefore you should raise your confidence in it. You shouldn't be certain of it, because you haven't ruled out that there could be some other hypothesis, usually. If you can rule out any other hypothesis, then you get the strict biconditional. Then you get, if and only if this theory is right, then we should see this observation. Then you've got a really, that's not even induction by confirmation anymore. That's just a straightforward modus ponens, right? Because your biconditional gives you if x then y, and also if y then x. So you just do if y then x, y therefore x. Yeah? Okay. So there's the third. There were three there. So there's three things that you can do with empirical generalizations. Three kind of inferences you can make. There's the inductive generalization. There's where you go from a sample to a population. There's the inductive syllogism, where you go from a population to a sample. And there's induction by confirmation, where you go from an observation that's surprising or unexpected and a hypothesis to the likelihood of that hypothesis. Okay, so moving on. Those were all empirical claims. We talked about empirical claims as claims about facts of the matter in the world. And they have to be sort of like, here's an object, there's another object. This object is beside that object. The cat is on the mat. Things like that. So those are empirical claims, and you know what observations you would make to tell whether they're true or false. Right? Is the cat on the mat? Yes or no? That's how you figure it out. Now, let's consider the class of normative claims. Like, for example, you should wash your hands, or this apple is great, or murder is wrong. Those are all saying things about what should be the case, what ought to be the case, and what's right or wrong. And these are not things like, I don't know what experiment you would run to figure out whether murder is wrong. Like, what would you observe? There's not really an observation, yeah.
You have to put it in a conditional.
You have to put it in a conditional.
Yeah.
So,
That's the only way to get around the problem of is odd.
right, right. So you have to say,
If you want your population to grow, then
murder is wrong. Right, right. Yeah.
What about you should wash your hands? I mean, that's like, presumably you don't want it to be like bacteria, which you know leads to bad things.
Nah. So recent studies have shown that kids who are exposed to bacteria actually have better immune systems than kids who are constantly scrubbed. Yeah, you reduce allergies by, actually in Australia they did a pilot study where they're feeding kids dirt pills. It was just dirt in a pill. And it reduced their allergies. You should still wash your hands though, because it's gross. Okay. The point of this is to distinguish normative claims from empirical claims. And this is something that I've been kind of playing fast and loose with the whole semester. I've been allowing you to make inferences from like purely descriptive claims to conclusions about what should be the case or what ought to be the case or what we should do. And that's, strictly speaking, not a good inference. Okay, because you cannot get from your hands are dirty to you should wash your hands without some kind of principle, right? Some kind of view about what's good or bad. Say, your hands are dirty and it's good to be clean, therefore you should wash your hands. That's a good inference. That's perfectly fine, right? But just your hands are dirty does not imply you should wash your hands, not all by itself. So I'm going to go over this in much more detail on Wednesday. I'm going to give a whole lecture about normativity and try to give you a reasonably nice framework for this. And basically it amounts to, if you haven't got a normative principle to start from, and people don't usually say they're normative principles, they just assume that everybody agrees with them, but you need a normative principle to get a normative conclusion, is the sum of it. Yeah?
So it seems like you would need to define what's good and bad to use these, right?
Basically. I mean,
Once those defined, then these are analytical statements, right? Or did I- sorry,
Maybe. It depends. You might get murder. So murder is wrong, I think, is plausibly an analytic statement because you define those killings that were morally wrong get defined as murder. This is one of the things in the interpretation of the Ten Commandments. So I can't remember what the translation is. So there's a debate about whether the translation should be "Thou shalt not kill" or "Thou shalt not murder." Every soldier in every war should worry if it was "Thou shalt not kill" because they very frequently kill. The question is whether the commandment includes that it's a morally outrageous killing or something like that. So murder is wrong, depending on how you interpret it, could be an analytic truth because you built wrongness into the word itself. So it's a normative word itself, isn't it? Murder. It's very hard to see a murder as being like, oh, that was great murder, guys. Yeah.
Also, just to build on that, it kind of also depends on where you are, in the country, because other people's I mean, some freedom fighters are viewed as terrorists are viewed as freedom
Right.
fighters. It's
Right.
supposedly either
Right.
it depends who you are.
So then it's the debate. The debate is about whether that was a murder or not. So if
Relative to some people.
if your militant group assassinates some politician, you would call it justice, and the general population would usually call it murder.
Absolutely.
Okay. So this is just another class of claims, and they're claims that you cannot really check just by looking, right? Yeah.
How's that second one not a descriptive claim?
This apple is great. Well, so that's not a descriptive claim because greatness is sort of a normative judgment, right? What makes an apple great? What would you measure to say the greatness level of an apple?
It's probably full of nutrients.
So the statement, I would say that I can say this apple is great, and that's me making a normative assessment of the apple. Like this satisfies whatever I want apples to be, but that doesn't necessarily tell you what I want apples to be, right? So if you say this apple's full of nutrients, now we can measure it. Or you say this apple is juicy, now we can measure it, right? Those are facts about that you could run an experiment, that nobody has to have opinions, nobody has to bring their worldview to bear on the question, nobody has to have a debate well, this one's too mealy, oh, this one's too juicy, I prefer it a little bit, I'm trying to saute it, so none of that stuff matters if what you're asking are how much vitamin C is in the skin of this apple. That's a descriptive question. But just to say it's great, two people could have totally different opinions about what makes an apple great. And what you need are some criteria for goodness to assess that one. So it's the need for the criteria of goodness. Yeah.
But wouldn't you run into that problem with a lot of stuff, like size?
Size is a bit different. So if you want to say, so it's
That's a big car, well, not to me. That's
right, right. So I'm very tall relative to my cat and very short relative to a mountain, but that's more it's not it's relative, but it's not relative to moral principles or something like that, or ethical principles or principles of value. So we'll get into this way more on Wednesday, and hopefully it'll be clearer. But just want to flag this right now as one of the kinds of statements that are not even clearly analytic, but they're also not empirical statements. And they're everywhere in arguments. So you have to be really sort of sensitive to this kind of statement and notice when it gets inserted, because often there's often slippery moves in arguments where you state a fact that everybody agrees on and then say, therefore, this normative thing, and what you might disagree on is what's good or bad. Right? So you have a difference of moral principle or moral opinion that doesn't get articulated. It's assumed that everybody's going to agree with you, but that's where the real controversy was what's good or bad in this situation. Okay. Here's another class of things we call foundational claims. So these are claims that maybe they could be analytic claims. Some of them aren't clearly analytic claims, but they're just claims that you have to believe in order to make sense of the world. So every event must have a cause. This is a foundational claim about how we understand causation in the world. Right? And what experiment would you do to prove this? I don't know. I don't know what you would test. Testing itself presupposes this principle. Running an experiment presupposes that you can identify the causes of an event. So you have to assume it in order to do empirical testing.
Isn't that by definition the first one?
So yeah, the first one is by definition. So in chess, rooks are the ones that can go forward and back and left and right. So it's another kind of foundational claim. It's foundational to the game of chess, you could say. And yeah, it's analytic. Yeah, that one's analytic.
Oh, okay.
How about this one? A statement and its negation are never both true. It's never the case that A is true and not A is true at the same time.
Is that also analytic?
It's tricky because like what do you derive that from? Yeah.
Yes, how do you judge this the validity of that statement without that statement being true?
Yeah. Yeah. I don't know how. I don't know. Philosophers don't know either, as far as I can tell. Yeah.
Is that the nature of foundational claim that's self-justifying?
It should be. Yeah. So exactly. So a foundational claim should be something that is either self-justifying or that you don't know how to, like, you can't even imagine what the rejecting it would look like or something like that. So we can debate about which claims are actually foundational, but I just want to mark this off as another category of statements that can be true or false, but they are not clearly empirical. Yeah? Okay. There's more about this in the textbook, so if you want another run through this, read the textbook. Yeah?
Foundational claim ever be false?
Well, if you could say rooks move diagonally, you said something false. You say the very definition of rooks is that move diagonally, I would say you said something false. Yeah. So something maybe that looks, so it depends on whether you want to make it a success term or not. So knowledge is a success term. You can never have knowledge of false things because that's what you mean. Knowledge is justified true belief, usually the analysis goes. So you can never have false knowledge. Similarly, you might want to be tempted to say you can never have false foundational claims because you built them being correct right into the concept of foundational claims. Whatever way you want to use that is fine.
So they have to be true is what we're establishing as like one of the properties of foundational claims.
Yeah. Yeah.
They
I mean,
be true within some reasonable interpretation, right? Like when you say rooks can move rooks by definition, or rooks can move diagonally, that's not foundational claim because it's not actually true at all.
now that I think about it, this is probably the way to say it. So they can't be wrong. So if it's going to be a foundational claim, it can't be wrong. If it looks like a foundational claim but it's wrong, then it's not a foundational claim. Is that going to parse it that way? Nothing important hangs on it, I think. Okay. So that was the criterial approach half of this. Now we're going to do, that was the good cop half. Now we're going to do the bad cop half where we identify some fallacies. Be careful with this stuff. The fallacies are what set me on my road to become an argument jerk for most of my life. I read my intro to informal reasoning was a book called Logical Self-Defense, and it was very like fighting style metaphors, and there was full of these fallacies, and the tendency when people learn this stuff is to throw the name of these fallacies at people while they're in conversation with them, which is a totally obnoxious thing to do. It's totally obnoxious to, especially the Latin names of them. None of these have Latin names, but like if you throw the Latin name of a fallacy at somebody, they are going to be confident that you are just a jerk. Unless you're 100% certain that they are like you just walked out of a class on fallacies, then that's a perfectly appropriate time to use that. Any other time probably is not going to help because, and what we'll see is that these fallacies are not always clear to identify. It's not always clear whether somebody's actually committing the fallacy or not. And that's the trick, because you can't just say the name of it and expect the other person to be convinced that they've committed it. You have to actually explain why they're committing it. And if you're explaining it, you might as well just forget the name of it and just explain it. You didn't actually save yourself any time by throwing the fancy term that you learned at university at them. Really, you have to explain it one way or the other, so just explain it. These names are for you to have in your head. One, to be able to identify these patterns, and two, to not be intimidated if somebody throws the name at you. So if somebody comes at you with one of these, now you'll be prepared. But don't come at people with them. I would recommend against it if you don't want people thinking that you're a jerk, from my vast experience of people thinking I'm a jerk. So, okay. So we'll just do these 4. There's a million fallacies, a million ways that arguments could go wrong. We'll just do these 4 today. These are fallacies of truth. Okay, so begging the question. An argument that assumes the conclusion in order to prove the conclusion is begging the question. It's also called a circular argument. So here's a couple of examples. I can't believe how much media attention celebrities get. They're not important. So there's the conclusion to be established, and here's a counter-argument. Of course they're important. They're shown on TV and magazines and on the internet all the time. So they're trying to show that the amount of media attention celebrities get is the right amount by citing the amount of media attention that celebrities get. Right? So the first person is trying to establish they should get less media attention because they're not important. And the second person has said, of course they're important. They get media attention. Do you see how that's begging the question? Right? You've assumed the thing to be argued about. So the thing in the first person is saying, look, importance does not track media attention. And the second person has said, well, of course they're important. Importance tracks media attention. Okay? So if you assume the thing to be proved, you've begged the question. People often use this wrong, by the way. They often use begging the question to mean raising the question. So, well, that's an interesting point. It begs the question of whether That's not how you should use this phrase. This phrase means if you say, I believe X because X, then you've begged the question. Okay, I think I have an example of this. So, and it's important to distinguish just having a weak argument from begging the question. So, a couple of examples. So try to decide, is this begging the question? So is this assuming the thing you're trying to prove, or is it just presenting a crappy argument? Morality is very important because without it, people would not behave according to moral principles. Begging the question. That's begging the question. Why?
Because morality and moral principles are basically the same thing.
Basically the same thing. And furthermore, so morality is very important. This is a normative claim. Notice this is a claim about what's good or bad. So morality is a thing of great importance because if it didn't exist, then there wouldn't be morality. And that's apparently important, which is the thing that you were trying to show.
Is every value judgment in this class going to be, I guess, a normative claim?
Every value judgment is a normative claim. Yeah, all value judgments are normative claims. The question is, some are like hypothetical, and some are categorical or something like that. So if you say, exercise is important to health, that's saying that it's valuable given this end. Whereas you might want to say more broadly, like, you should be a good person, and that's not just sort of to some end, that's sort of an intrinsic value judgment. So, right, okay, here's another one. Hockey is the most fun sport in the world, and I know that because I have fun playing hockey. Is that begging the question or just a bad argument?
Bad argument.
I think that's just a bad argument. What it is a bad inductive generalization. So you're saying from a sample of one, me playing hockey, I can infer that everybody in the world has the most fun playing hockey. It's just a really weak inductive generalization. Yeah? Good. It's okay to lie to authorities if this is in the national interest, because if something is very important for the country to flourish, then lying is acceptable in that case. Okay, why? Yeah, yeah. Lying is okay in those cases where lying is okay. Right? You just assumed the thing that you're trying to show. Here's another version. Lying to authorities is always acceptable if the lie advances the national interest. After all, Krolicki lied to the Senate last year, and now we know his lie was instrumental in saving the lives of government agents. That's just a weak argument. Or maybe it's not even that weak. No, it is a weak argument. It's a weak argument because of the strength of the conclusion trying to be established, right? So lying to the authorities is always acceptable if the lie advances the national interest. So this might be you might be convinced. So if you're convinced that saving the lives of government agents is a good thing, then you might thereby be convinced that in this case lying was a good thing. But that's not to say that it'll be true in all cases. Again, this is a faulty inductive generalization. Yeah? Okay, it's not begging the question, it's just a bad argument. Okay, so once again, begging the question is assuming the thing that you're trying to prove. Often just phrase it in different ways, but you're not giving a reason to believe the thing if you have to assume it in order to show it. Good. Okay, so here's an easy one. Inconsistency. When an argument violates the law of non-contradiction, we just say things that cannot be true at the same time. Nobody drives in New York. There's too much traffic. Right? Those two things can't both be true. Clearly, there are lots of people driving in New York. I can't come out tonight. I'm too sick, and also I'm going out with James instead. Either you're too sick or you're going out. Those two things can't both be true at the same time. I hope this one's the super easy one. Like, if you say inconsistent things that can't possibly be true at the same time, and you assert that they're both true, then you've made this fallacy. Yeah? Yeah.
So if you're trying to prove something and you assume a premise that by definition is just on its own proves the statement, right? Then is that begging the question?
So what it depends on is whether the statement is itself the thing that you're trying to prove. So like, if I'm trying to prove an analytic truth, then a certain, a premise that's certain gives me the analytic truth. That's fine, yeah, right? So, can you give an example?
So, I'm trying to prove, let's say, 2 is an even number, and then you say, okay,
That's one of those tricky math things. Probably the proof of that is like 60 pages of set theory.
no, I'm just trying to get something, all other numbers, every second number is an even number, right?
Right.
From 0.
Right.
Now, that's my premise, and I'm trying to prove that 2 is an even number, by definition it proves it, but
I think you.
in itself is using that every second number is proved, so.
Yeah, I think that's begging the question. Yeah, I think that's begging the question. Okay. Any problem with inconsistency? Should be fine, right? The only kinds of exceptions that I can imagine here are when you do inconsistent hypotheticals. So you can say, well, if this was true, then that would be true, and if it was false, then that would be true. But they don't have to. You're not asserting that they're both true. You're just saying what would follow from them. Or if you do what's called a reductio ad absurdum. So if you say, look, if we assume that this is true, then this and that follows, and that it generates a contradiction. Therefore, it's false. You generated a contradiction, but you haven't asserted a contradiction. Something like that. Sorry, that was unclear. Don't contradict yourself is the point here. This is fairly straightforward. I'm making this more complicated than it should be. Don't contradict yourself in arguments. People will be unhappy with you and not believe you. Yeah? Okay. Equivocation. So a word that means two different things and is used as though it means only one. So this is to draw on Luke's example from last time. All rivers have banks. All banks have vaults. Therefore, all rivers have vaults. That's a good one. Right? So if all of those words are being used consistently, that's a perfectly valid argument. It's with false premises. If those words are being used in different ways, then those are true premises and an invalid argument, because you're just using them in two different ways here. Another one, criminal actions are illegal, and all murder trials are criminal actions, thus all murder trials are illegal. So you're using criminal actions as either an action that is criminal or an action that is about some criminality, right? You're just using the same phrase in two quite different ways. So the fallacy of equivocation. Good? Do a quick example here. So there's a lot of talk these days about how we shouldn't discriminate. Discriminate one. Well, I don't agree at all. Everybody discriminates all the time. It's unavoidable. We discriminate when selecting a wine or buying a car or choosing a new wallpaper. We discriminate when deciding which friends to invite to a party or which candidate to vote for. We discriminate when we hire someone or admit someone to a college. We always make such decisions on the basis of qualities we admire, i.e. we discriminate. So there's nothing wrong with discrimination, too. So this is a argument that commits, I would submit to you, the fallacy of equivocation, because there's a lot of talk these days about how we shouldn't discriminate. It's typically about like, don't be racist, don't be homophobic, that kind of thing. That's what they mean when they say don't discriminate. Now, you might not agree that those are two different uses of the word discriminate. Right? So if you think that this is a good argument, that means that you think those two, discrimination 1 and discrimination 2, are being used in the same way. I would suggest that they're not. Because in the one case we talk about discrimination against people for arbitrary reasons. That's mainly what when people talk about don't discriminate against people, what they mean is don't discriminate against people for arbitrary reasons or reasons that are beyond their control or something like that. They don't mean don't tell the difference between good wine and bad wine, right? And the fact that people distinguish between good wine and bad wine does not entail that it's okay to discriminate against people on arbitrary bases, right? So we're using the word discriminate there in two importantly different ways, but we don't articulate it, yeah? And this is typical, like this is not a particularly poorly formed like set of words. People normally use words in ways that could be ambiguous. It's a totally normal feature of language. And it's just that when you're in the context of an argument, often it's crucially important to get more clear about exactly how you're using words. So if I was in a conversation with this person, I would say, okay, what do you mean discriminate? Let's clear this up, because you seem to be using it in two different ways, and I think that they're importantly different. So you can get the everyone discriminates in the sense of two, like everyone makes discriminations between things they like and they don't like, but that does not entail that everybody discriminates in the sense of arbitrarily treating some people poorly and some people well. And so it's not the case that people always do that, although it is the case that people always do decide between like, I prefer juice over water or something like that, right? Yeah.
Also appealing to like status quo is pretty better than
Right. So even if you were in a society which was full of people who discriminate openly, that wouldn't make it good, would it? Right. Good. Okay. So there's equivocation. And the last one we'll do is false dichotomy. So when two options are presented as the only options, but they are not, in fact, the only options. So all mammals are either birds, or all animals are either mammals or fish. Birds aren't fish, so they must be mammals. Well, those aren't the only kind of animals, obviously. There's reptiles, there's birds, there's all kinds of things that are neither mammals or fish. If you can't sit still in class, you're going to die homeless and alone. Well, those aren't the only options. They're just not. Right. So presenting an either or as strict, like, look, you got to pick one or the other, and then if you shoot down one, then the person's forced to accept the other. Well, that works if only those are the only options, and furthermore, if they're exclusive. So you can't have rice and fish for dinner. Well, actually, you totally can. Like, you can have both. Right. So here's an example. The outboard motor I bought last year turned out to be a real lemon. As soon as the warranty expired, everything started going wrong. It cost me over $600 in repairs so far this year. The trouble is, there's nothing I can do about it. Thought about suing the manufacturer, but the lawyer's fee would cost more than I could ever hope to win. Okay. So where the dichotomy here is, yeah.
You intend to sue the lawyer?
Right. So my options are get a lawyer and sue the company, or do nothing. Tons of other stuff you could do. You could write a bad review on the internet. You could complain on social media. You could write a letter. Like, there are a whole bunch of options that you have in those cases that are not included in this dichotomy of either lawyering up or do absolutely nothing. Yeah? Okay. All right, so that was that. These are all about checking premises for acceptability. Next time we'll do relevance and adequacy. Actually, next time we'll do normativity, but after that, relevance and adequacy. So what I propose now is that we do a short, well, fairly short argument analysis. So we're going to go through these 7 steps, basically, I have a bunch of printouts of like 1, 2, 3, 4, 5 short paragraphs from a CBC article. So I'll hand these out, and what you'll do is just do these steps. So you can identify the conclusion of the argument being made, and I want to warn you that there is some static in this signal, so not every sentence in this is part of the argument. Your job here is to identify what part is the argument. It should be fairly clear, and then identify the conclusion of the argument, identify the premises, and kind of clean them up for yourself. So you're going to clean these premises up, write them in a short, snappy way that's easy for you to remember, easy for you to hold in your head, and then kind of figure out the structure of the argument, and then we'll assess it. We'll go through the rest of the steps. I think that's the best way to learn this stuff is just do a bunch of arguments. So I got, half a page from a CBC article, and then I got 1 Reddit comment as a counter argument. I don't know if we'll get to the Reddit comment, but we'll start with the CBC article and then go from there. Okay? Okay. So